Okay, so you say other relationship, the other relationship being area. Area is supposed to be 200, and that's xy. It doesn't really matter, but which did you solve for, x or y?
Well, X.
Okay. Either way, would you agree that it's an inverse relationship, 200 divided by whatever the other one is? So if I put that in, I get the perimeter is 2x plus 2 times 200 over x. I could probably take the derivative okay on that, but it helps me to make it as clean as possible before I begin my calculus. So a clean perimeter equation is 2x plus 400x to the negative first, yeah? Now what do? Find the derivative, hoping to find a place where the change in perimeter goes from decreasing to increasing to find a min. So let's go P prime. Is that a derivative with respect to time or just derivative in perimeter with respect to x changes? X changes. It's how x changes affect perimeter. And there's no time to it. So 2 minus 400x to the negative 2. Did you get the derivative correct? Good. Let's find the critical numbers here because that's where the thing will change signs. The derivative will change signs. 2 minus 400 over x squared. There is an algebra component to this. I would give maybe a common denominator. 2x squared minus 400 over x squared is 0 or undefined. See? P prime is undefined at x equals 0, but can x equal 0?
Can we go a little slower?
Oh, sure. I'm just assuming we were verifying that you already did. Right?
Well, we told you, well, no, we're ready for something else.
Oh, sorry. Should I slow down?
Yeah.
Okay, here, I'll erase this.
No, wait, what? No, we got that part.
Oh, then you should be fine. Keep going. I'll slow down. You're right. Sorry. Can't help being super fast.
It's 1-0 and
Curse really great. Oh, I like it. Super curse for speed and genius.
no, wait, what's X though? Okay, so very good. So this 12 minus 400, so then L equals 10 squared so that was where it was, and then I just multiplied everything. Oh.
All right. Here we go. Now are we ready, ladies? Come on. Gee, I do any more for you. I'm going to be writing on your paper. I did. Yes. Oh. Why is it squared? All right, are you ready?
We did it in this one.
Okay. Bridget, are we ready? Start. All right, let's do it. The derivative, as we said before I went too fast to something like this, a lot of people would do this a little different algebra than I would. Some people would move the 2 and saw. Was taught that you should not do that because sometimes you forget the critical number if you multiply the x squared over. So that's why you'll see me do it this way. This P prime is undefined if x equals 0, but that is not in the what I consider the feasible domain for this problem. X can't be 0 for this field. So P prime is 0 if the numerator is 0. And what x makes the numerator 0? was just messing with you. There's no 2 there. So 2x squared equals, or x squared equals 200, so x is 2 root 10, I heard somebody say. And I agree. That's what I said, 10 root 2, sorry. 10 root 2 is what, about 14? Yeah, that sounds about good. 10 root 2, what are the units on that? Yards. And let's talk answering the question. Find the minimum amount of fencing required. If x is 10 root 2, I need to find the y. What's y? 200 over x, or 200 over 10 root 2. That's 2 over root 2. Nope. It's 20 over root 2. Do you agree? And isn't that 20 root 2 over 2, or also 10 root 2? From that we conclude the best possible configuration is a square, 10 root 2 by 10 root 2. And so what's the perimeter? If each side is 10 root 2 and there are 4 sides, 40 root 2 yards is the least possible thing. Or in other words, 1.4, you need about 28 yards of fence, or 280 yards of fence. Okay? Are you with me? Cool. Let's talk. This lesson, I kind of rearranged stuff a little to, for lots of reasons. In this case, it's so I can get a lot of AP practice earlier than the book has it. So this really has 2 ideas: using your calculator to evaluate definite integrals, and fundamental theorem of calculus rearrangement. So, would you get out your calculator, please? If you were to evaluate this using your calculator, it's gold because, first of all, that couldn't be integrated. You could not find an antiderivative that it doesn't calculate. Your calculator, it's important to know, Ms. Cannon always harps on this, I know, but it's important to know your calculator does 4 things. What are they? Add, subtract, multiply, and divide. Your calculator knows no trigonometry, it does no sine, it does sine of 30 by using basically calculus. Sine of 30 is an amount to an area under the curve calculation. All of those programs that your calculator is programmed to do, they amount to adding, subtracting, multiplying, and dividing. That's all it can do. It's just a really good estimator. It's not a fine exact, all right? When you do this, it's not actually integrating this. It's important to you to know that. It's actually breaking dx's. It's calculating several tens of thousands of rectangle areas. It uses dx's I think for the Inspire, every 100,000 wide times 100,000 different heights and adds them all just like that. The best place to go, and you might write this in your notes if you have the Inspire, is, never mind. Best, easiest way to get an integral is Shift plus. That's the quickest way to get a definite integral. Shift plus, got a definite integral. That's the least amount of keystrokes. If you have an 84, it's Math 9. So, Shift plus, boom, definite integral. You see that?
Whoa.
Okay. Shift is right here next to Control, plus obviously no. First type in the limits of integration, 0 to 7. Then the integrand, e to the 3 root x. Get out of the root by scrolling over, plus, get out of the exponent by scrolling over, plus sine of x. Make sure you get out of parentheses appropriately. Dx, I feel like that's all. Hit enter. And 4,316.4606. Way down. 4,316 point, give me 3 more decimals. So I would take 460, I'd take 461. I would take more than 3 decimals, 4606. Always give me at least 3 decimals. Are you understanding okay? Huh? Why do I want it to go 3 decimals? No, you want it to go more. Oh, you should set your defaults to Oh, yeah, that's that. Settings. Document settings, actually, handheld settings. Settings, sorry, home. That'll change later. You usually work from scratch, right? Sorry. Try the next one on your own, sorry.
That little sign.
I don't know what's going on. Just a second, Lainey. Let me have the mental block. Did you get this one? What'd you get? Actually, do the next two, please. Sorry. This one requires you to store the x-intercept. What'd you get for the first example, please? 1.2799. Do we all agree? Okay, try the next one. Part of the class is to be able to use a value and then store it to use later. So make sure that you can do that. I will go behind you and see if I can also do it. Sign up. What was the next? All right. Your graph looks something like that. Yes? All right. Now, if I want the first quadrant area, the calculator can do that by using a definite interval, right? We need to know what the boundaries are. I know it's going through 0 on one side, but I need that first. So you need to find that point. How do I find that point? Is that, now I don't know if it's a minimum, but I definitely know it'll close the area at 0. So I want to find the 0. I might actually zoom in a little. Right there. What the heck? Oh man, does it not cross 0? Does it?
I don't think so.
That's a problem. Let's give the trig a little help. Are you finding the same thing, that it doesn't have a 0?
Yeah.
Let's change it to 5. That'll give the trig a little help. Maybe cause it to 0 out. Sorry about that bad example. Does that still no? It does go underneath? Okay, perfect. All right. Now, we want to find the first quadrant area. So do we want the left-hand 0 or the right-hand 0? The left-hand 0. Menu, analyze graph, 0, and I'm going to go a little, what the heck? A little to the left and a little to the right. And you get a 0 at 4.10462. Okay, now you're going to need that stored. You do not want to ever round in the middle of a problem. That's called intermediate rounding. So we want to store that value. First click on it. It should be highlighted now, yes? Okay, now hit vars. So I'll ask you, do you want to store the var? The answer is yes. I want to store the variable. Let's call it A. 4.10462 is stored to A now. You with me so far? Okay, now I want to make the area calculation. I'm going to go from 0 to 4.1046 or 104, but in my mind I'm going to really use A, not the rounded version. You with me? Now, in terms of what's in the integral, what am I going to integrate? The function, yeah? Are you with me? So x plus 5 sine of x. To have the calculator do that, go to the home screen. Hit Shift plus to get a definite integral. Limits of integration are from 0 to A. Use the stored version, not the rounded version, 0 to A. Now, for the function, you already have it typed in, so you could just type in or call up the function f1 rather than retype it, which leads to some errors in typing. Okay, so from 0 to A, the antiderivative, and the area is 16.2791 approximately. Do you agree? All right. So the skill there is to store a value, like a limit of integration, and use it later. Are we good? Can you do that? Okay, cool. Now let's move on to another idea. And this is a big one. Fundamental theorem of calculus, part 2 of mini. The fundamental theorem of calculus, I hope you remember, is the idea that a definite integral, you count the area under a definite integral, it's a two-step process. You take the antiderivative, which, what's the antiderivative of f prime? F. And you evaluate it at the upper limit and subtract away at the lower limit. The definite integral is evaluated by taking the antiderivative at the upper minus the antiderivative at the lower, right? All right. Now then, it's often the case that they won't give you the pieces you expect. Sometimes you'll be given the definite integral. You'll know what it equals. And you'll actually know one of these points, and you'll be looking for the other. So sometimes you're going to be rearranging this. For example, if I wanted to find f at b, then I could move f at a over by adding it over, and then adding it to the definite integral value. That's just algebraic manipulation, moving stuff around in an algebra equation. No big deal. The meaning of that is actually has meaning. It's, you could say, is the ending position equals the starting position plus the changing position. We'll talk about that tomorrow. You could also say you wanted f at a. If you solve this for f at a, what's f at a equal? Okay, now imagine if you want it to be positive, first you would add it over there and then subtract the integral back. So it would be f at b minus, and tomorrow we'll see that that's actually the starting position is the ending position. Take back the change that happened. Take away the change. All right? So Say I have a case like this. If you're given the definite integral's value is 6, I'm telling you it's 6, and I give you that f at 0 is -2, find f at 4. Start with, is it f, oops, start with the fundamental theorem, which is the antiderivative from 0 to 4 of f prime equals f at 4 minus f at 0. Without the values they're giving me, isn't that the fundamental theorem of calculus? All right. Now, it's two things. You either substitute and solve or solve and substitute. Do you want to solve first for f of 4 and then put stuff in, or put stuff in first? Solve for f. Okay, so if you solve for f of 4, what is it equal to? You would have to get rid of minus f at 0, so you would add it over. So that would be f at 0 plus the integral, yeah? All right, now you substitute. What is f at 0? -2. What's the integral value? 6. So f at 4 must be 4. Obviously, that's coincidence. That's really going to fit those two. You with me?
Yes.
All right. Try those 3 then. I would suggest you write the fundamental theorem, rearrange, and solve, or substitute. Fundamental theorem, rearrange, solve. Although you can substitute the numbers in first. You get -3 for the first one. Okay. What you get for the second one? Done? Okay. Slow down. -10 for the second one. If you're not getting those so far, then either look at what I did and compare, or ask me what you're doing wrong. This is a really important skill, so you definitely want to do this one. It's right up you guys' alley. You're really good at algebra and manipulation of formulas. You do that in science at school all the time, so I imagine this will go pretty well. I hope. That's not to say you shouldn't ask if you are not getting it. Oh, so that's what we solved for. And -3 for the last one? Okay, that one was the easiest. All right, now let's move a little past that and use that in conjunction with two ideas. It's very common that you're asked to demonstrate your fundamental theorem knowledge with a combination of geometry problems, all right? So this is the graph of f prime. And I give you a couple of facts. F at 0 is 4, and they want f at 3, f at 6, and f at -3. Now, it is definitely not the intention. Do not write the equation and integrate. That is not the intention. The intention is that you talk a definite integral and areas under the curve, and you relate it through the fundamental theorem of calculus. So, for example, when I say use FTC, relate what you know, a known fact, and a wanted fact. So, for example, I know f at 0, and one of the things I'm asked for is f at 3. Okay? If I relate those through a definite integral, then I could say 0 and 3 under f prime. The area, that definite integral would be the antiderivative f at 3 minus the antiderivative at 0. That's the intention, is that you relate the given the initial condition to one of the things you want. Then it's starting to look like a problem we've done. You isolate what you want. We want f at 3. So if I isolate f at 3, then I would add over f at 0. And f at 3 would be the initial f at 0 plus the integral. Are you with me? Okay. At that point, then, you use geometry to find the area, the integral area. We're not given the integral value like the ones above, and we're not going to integrate to find that area. We're going to use some geometry. That area is the area under the curve from 0 to 3. Geometrically speaking, and how you find it. Pi r squared over 4. Okay, so we're talking about f at 0 we're given, plus pi r squared over 4. And what is the radius? Radius. So I'm feeling something like f at 3 is 4 plus 9 pi over 4. We'll just leave it like that. Okay, are you with me? All right. Would you then try f at 6? Using that same idea. Write a definite integral relating what you want, f at 6, to something you know. Now, we actually know two things at this point. What do we know? F at 0 and f at 3. And if you have super confidence in your f at 3, then feel free to build off of it. Or you can relate all the way back to f at 0, whatever you prefer. Actually, so we're all on the same page. Do you want to relate it to f at 3 or f at 0? Okay. You do not have confidence. relationship is the fundamental theorem. Definite integral under f prime equals f at the last endpoint minus f at the starting. So what are the two geometric ideas that we're going to get the area into the curve? 0 to 6, that area is actually going to consist of two geometric figures, right? So I'm feeling like pi r squared over 4 plus base height over 2. So maybe 4 plus 9 pi over 4 plus 4 by 3 over 2. Yeah? Unless you disagree. Do you agree? Okay. So that's what, 6 plus 4, so let's simplify 10 plus 9 pi over 4. I feel like that's pretty easy. Did I make a mistake? What? You're saying the base is 3, not 4. And I agree. The base is 3, not 4. And so that's 3 by 3. I don't know why I was thinking 4. 3 by 3 over 2. Oh, that's right. I meant to change it so it wasn't ugly, but that's right. 9 halves plus 8 halves is 17 halves plus 9 pi over 4. Thank you. Is that better? Do you agree? Okay. Last but not least, would you find f at -3, which actually causes you to rearrange a little differently. So find f at -3. Imagine just going one of the two different ways, and you're going to have to look at things. They both will yield the right answer if you do things well. Ready? Or not yet?
Not yet.
Okay. Ready?
Yes.
Okay. I can imagine you doing this one of two ways. One is to, first of all, do you agree? Well, I want to relate f at -3, which is what I want, to what I'm given f at 0. So we're definitely going to have -3 and 0 there. Question is, which one do you put where? Doesn't matter. If you put -3 first, that to me makes sense because you're going left to right along x. But it's f at the upper, which in this case would be 0 minus f at the lower, right? If you were to rearrange that for f at -3, I would add it over there and subtract this over here. So f at 0 minus that, yeah? All right. This guy, f at 0 to -3, this would be lower minus upper, but that's gonna be, ooh, no, you don't wanna do that. Yeah, don't do this. Don't do this. Unless you know the repercussions of switching those numbers, don't do that. I don't wanna go there. Unless, if you had Miss Cannon last year and that's how you do things, fine, but don't do that if you're just learning this, all right? So go left to right, please. Lower to upper. Don't worry about what you want to what you need. Go left to right. Okay? So, say again. Along the number line, -3 is first and 0 is second. So that's oh, so you mean over here? Or here?
Yeah.
Isn't it at the upper minus at the lower? And the upper is 0 and the lower is -3. Anytime I do this, it's at the upper limit first and the lower limit second,
We're
right?
talking about the after the end.
This guy?
No, like the very beginning, like yeah, there.
Yeah, that's left to right.
That is left, right.
Starts here. You're starting here, right? This is the starting point of the interval. And that's left on the region. And right is 0. Do you agree that -3 is left?
Yeah.
Okay. So that goes to left. All right. When I rearrange this, what is f at 0? 4 minus pi r squared over 4. So you should have something like 4 minus 9 pi over 4. Minus, not plus. Minus. Okay? And last but not least, fundamental theorem with calculator here, right? Given that f prime is e to the 2x plus 1, I think that says 0.2x plus 1, doesn't it? And f at 0, not given. F at 0, sorry, write this in, I forgot to give you f at 0. Say f at 0 was 2. Find f at 3. Sorry, I didn't type in f at 0, or write in f at 0. All right, you have a derivative, you have a given f point, and you want a different f point. So use the fundamental theorem of calculus. The fundamental theorem would be the integral from where to where? 0 to 3 of f prime by fundamental theorem that equals the antiderivative, which is f, at the upper limit 3 minus the lower limit 0. Start by writing the fundamental theorem. Now rearrange. What do I want to isolate? F at 3. F at 3, I would have to add f at 0 over, so f at 0 plus 0 to 3 of f prime. Please try and write the integral last. Okay, you don't want to write the integral first because then it's not clear if the rest of it following it is in the integral or not. So you typically like to write the integral second. All right, at that point then it's calculator time. Let's say we pick up our calculator and go f at 0, which is 2 plus shift plus the integral from 0 to 3. I could have put the function in, but because this is just only one question, I don't really think it's necessary. Let's just type in the integrand, what the function is. So what is the function? E to the point 2 x plus 1. You do have to put the integrand or the differential in. I get 13.1737. Yes? Okay. 13.1737. That's it. All right. We will practice this aplenty tomorrow. Or not. Oh, we will practice this tomorrow. And yeah. What homeworks do you have? You still have 52? Oh, we didn't finish the use of? We did some some turned in U sub and some didn't, but I want the U sub today. If you have more questions on the U sub, come in 7th hour. 52. Questions on 52. 25. 41. And 1. And 2. 25, 21. Which one? 4?
Yeah.
All right. Okay. 25. Ooh, good one. Okay. Yeah, 25 is a little wacky. I think their intention is that you'll use the definition of the derivative. This requires you to think about it in a definition of the derivative way. So, what's the definition of the derivative of g prime, or g? Limit, let's use the first definition. The limit as h goes to 0 of, normally I'd put f, but in this case it must be talking about g, so g of minus over. Okay, now, they gave you the top. The limit is there. The h you have to put in yourself, but the top is 3xh plus 3 halves h squared. So the intention is that you substitute in the top. Now, if we try to put in h of 0, we get 0 over 0, but which is a problem, but we can get away with that problem by taking out an h, yeah? If I take out an h, what's left? Plus 3 halves h. Now I can do the limit. The limit, as h goes to 0, 3x stays, and the other guy goes to 0. So it is just 3x. The derivative must have been 3x. You follow? 21.
Good morning, Devil Jaguars. Please rise to the Pledge of Allegiance. Begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. All students, the winner of the My Favorite Book library drawing is Ciara Nobler. Ciara wins an Amazon gift card worth $10. Congratulations, Ciara. Wow. Come to the library. Junior High Student Council meets today in Mitsubishi room.
Okay. They want you to first the volume is pi r squared h, yeah?
Today they're in 7th hour, 8th college.
Now the surface area, what is it?
Stop by and check out the new block schedule where students focus on one class at a time.
Area of the base plus
Opportunities for every student
area of the base.
covers
I'll do a little. I'll do this in 2 steps.
Tomorrow, Northern Arizona
2 times the area of the base.
Flagstaff, Arizona will be visiting with prospective students. All band and orchestra members who would like to be a part of the musical pit for curtains, please remember to stop by the drummer room, the senior hall, the after school for a brief
Okay.
meeting.
Now that's 3 variables, r
Senior high students,
and h.
there will be a girls' soccer
Area, yeah?
meet this Thursday at 2:30
Now let's
in the cafeteria
substitute.
for all athletes interested in playing.
4 h. H is 300 over
Congratulations to our Devlin Gymnast.
pi r squared.
Emily Belmonte and the Green Mountain team had a 4A state runner-up finish. She had a 2nd, 4th, and 6th all around. Tegan McDonald finished 13th in 4A, and her Bear Creek team, Kendall Bronco, finished 8th in 4A. Peyton Schurig and her Lakewood High School team finished 9th in 5A. Jack, tonight, come to the Chipotle on the
Let's clean this up a little.
for DHS tiers,
Because I don't wanna take the derivative of that product to a mess, right?
bring your friends,
So
family, and
this would be
teammates.
600 R to the negative 1. If the highs cancel, and I clean up the R's.
The female student
Now,
athlete of the month for November is
find where S prime
2018 marks the fourth
goes
year that has been
negative to positive for a minute.
playing 2 on JV and 2 years on varsity. Leah was
Take the
voted one of our
derivative.
3 senior captains, unanimously
Take the
by our
derivative.
varsity team. She is hardworking, positive, and extremely caring, all not only for herself, but all of her
Minus.
teammates as well. As a senior, Leah continues to push for excellence academically, taking
600
full
over
classes
600
and
R to the negative
taking
second.
pride in
Yeah.
her overall performance. She is
Did we?
also earned first team all conference for the
Clean it up a little.
2018 season. Male Student Athlete of the Month for November is Alan Lee. Alan has been involved in our program for the last 4 years, 3 at the varsity level. Each year, Alan has become not only a stronger and more technically sound player, but also a leader to which the rest of the program can look up to. Opposing coaches also have developed a great respect for Alan and have awarded his efforts over the
So
past year.
S prime is undefined at R equals 0, but that's ridiculous.
Often be seen volunteering his time to worthy cause. Congratulations to these fine student athletes.
Okay, S prime is 0
Veterans Day is our new coaching and as we focus on starting chain
at the
reaction,
numerator equal to 0.
appreciation, and compassion for others, we are excited to provide all veterans with a Veterans Day appreciation. Please invite any veterans you know to participate in activities at noon on November.
So R is the cube root of 150 over pi.
That's all your announcements. Have a great day.
And I don't know what the question asked, but that should be the question. I will, I'll put 1, 2, and 4 up on my website at lunch. And get 52 to me at the end of the day. I'll come in 7th hour. Oh, sure.